We follow one rule on space-time. It's never aliens. But every rule has an exception, and this rule is no exception, because it's never aliens until it is. So, is it aliens yet? "45 years ago, a pair of small Earth spacecraft inserted themselves into orbit around Mars. Each dropped landing craft which descended to opposite sides of the planet. This was the Viking mission, the first successful Martian landing by the US. The landers performed multiple experiments to investigate the Martian soil for signs of living microbes. In one of these, samples were injected with a nutrient solution laced with radioactive carbon. The idea of this labelled release experiment was that living microbes would metabolize the nutrients and emit radioactive gases. Stunningly, both landers reported positive results, 4,000 kilometers apart from each other. As a control, identical soil samples were first heated to 160 Celsius, in which case no response was observed, as you might expect if the microbes had been fried. It seemed like a slam-dunk detection of life on Mars, and yet no other Mars mission has managed to detect clear biosignatures. And today, the scientific consensus is that the labelled release experiment did in fact not detect life. It seems that every few years, for at least the past half a century, we get another tantalising hint of the existence of alien life. But they all seem to fizzle out. At least we never get the grand announcement that this particular evidence of aliens turns out to be aliens. So what happened to all of this evidence? Are any of them still credible? And what's it going to take for scientists to decide that any given line of evidence adds up to proof? Or are scientists just too skeptical for that to ever happen? Let's start, or rather continue, with our quest to find evidence of primitive life in our solar system. The Viking mission's labelled release experiment sure looked like it had detected life, except for one major difference. After the initial detection of these supposed microbe metabolites, additional shots of nutrients were injected. Now, when this is done with Earth samples, new bursts of gas are always observed as the microbes wake up and start feeding, but not so in the Martian samples. Subsequent injections of nutrients yielded no response. This came to be interpreted as evidence that the initial reaction was not biological, but rather purely chemical. And NASA's 2006 Phoenix lander found a possible culprit, perchlorate in the Martian soil. This toxic chemical, or its byproduct hypochlorate, would be expected to break apart the organic compounds in the nutrients, producing gases that mimicked metabolites of biological activity. And while microbes should multiply after feeding, a simple chemical like this would be depleted, explaining the lack of response after the first nutrient injection. Hypochlorite should also be destroyed at high temperatures, explaining the non-detection in the control sample. Let's look at some of the other hints in our solar system. Still on Martian life, what ever happened to the supposed fossil microbe found in that Martian meteorite? In 1996, scientists discovered elongated mineral structures that looked for all the world like fossilized bacteria, but embedded deep in a Martian meteorite that had been found in Antarctica. The scientists also found magnetite, a common byproduct of microbial metabolism, which at the time had no known abiotic source. This meteorite was special in other ways too. It had formed over 4 billion years ago, back when Mars had liquid water. In fact, its geology required the presence of liquid water. This was a compelling enough hint at life that Bill Clinton made a special TV announcement. So why don't we count this as the discovery of life on Mars? Well, over the past couple of decades, researchers have shown how these same structures, the fossils and the magnetite, can be produced by the sort of chemical reactions that you might have expected to have happened in this meteorite. It's also difficult to rule out contamination by Earth microbes. After all, the thing had been buried in Antarctica for millions of years before geologists cut it open. No one has ever demonstrated convincingly that these are not Martian fossils, but they don't need to. When you're talking about the discovery of alien life, the burden of proof rests very heavily on the shoulders of the discoverer. It has to be implausible that the result could be anything but life, and that's just not the case with the would-be Martian fossils. And this is the same reason that we are forced to reject, or at least be very cautious about, all prior claims of evidence of alien life. For example, the occasional spikes in methane detected by the Curiosity rover on Mars could be microbe farts, but could also be any one of a number of geochemical processes. The red patterning on the surface of Jupiter's moon Europa could be slime colonies, but could also be rust. This brings us to Venus. In September 2020, astronomers reported the signature of phosphine in the upper atmosphere of Venus from radio data taken with ALMA, the Atacama Large Millimeter Submillimeter Array. Phosphine is a common byproduct of biological activity on Earth, but it was very difficult to come up with a non-living source of so much of it on Venus. This may have generated the most excitement since the Martian meteorite thing. Now, we went into the details soon after the announcement, so today I just want to answer the question, what happened to this result? Well, as you can imagine, for such a huge claim, it sparked very careful scrutiny and analysis. A few independent teams found issues with the original data processing, and their new analysis found little to no phosphine on Venus. The original team also redid their analysis and now claim a 7-fold lower abundance of phosphine than in their original report, placing it at the level of a tentative detection. So, the phosphine hasn't quite gone away, but even if it is actually present, it's now much easier to explain with non-biological processes. Once again, the burden of proof is on the new claim, and the evidence just doesn't cut it. There's a relevant quote from Sherlock Holmes on this point. When you have eliminated the impossible, whatever remains, however improbable, must be the truth. Now, there's a certain Harvard astrophysicist who's fond of saying this in reference to his many claims that some new astrophysical phenomenon might be aliens. And the statement is logically correct. Improbable does beat impossible in terms of likelihood. But it's exactly this illusion of logic that makes the Sherlock argument so misleading, and by far the most common cause of false declarations that it must be aliens because it couldn't be anything else. The universe is weirder than we can ever imagine, and it's arrogant to assume that you've thought of every possible non-alien phenomenon that could lead to a particular observation. A great example of this is Oumuamua, that weird object that flew through our solar system a few years back. Oumuamua appeared as a very faint pulsing reddish spot that slung around the inner solar system just fast enough that it most likely fell from interstellar space. Its pulsing was interpreted as being due to it being an elongated object tumbling. Besides its interstellar origin, the weirdest thing about it was that it appeared to accelerate on its way out of the solar system, in exactly the same way that comets do due to outgassing. Ices vaporizing in the sun's radiation and acting like jets. In the case of comets, this also results in the classic comet tails. But Oumuamua had no tail. There was a claim by a Harvard astrophysicist that the most likely explanation for Oumuamua is that it's an alien artifact, in particular a light sail, probably a broken one. Now, we covered all of this before, both the discovery of Oumuamua and a clarification that there are huge problems with the alien hypothesis. But why not aliens if there's no accepted natural explanation? Well, the answer is simple. Because there are more things in heaven and earth than are dreamt of in your philosophy. And, lo and behold, since the publication of our video, a far more reasonable explanation has been proposed. I'm actually going to direct you to Anton Petrov's excellent channel for a really clear, in-depth analysis. But in short, Oumuamua is very well explained as a shard of an extrasolar ice world similar to Pluto, ejected into interstellar space by an impact. Pluto also has a red tinge due to radiation processing its surface methane into hydrocarbons, and this also explains the acceleration. It will be due to outgassing of the nitrogen ice abundant on such worlds. That would still act like a jet, but should be invisible. Now, this may well not be the correct or the entire explanation, but it does make it very clear that there are perfectly plausible natural explanations for Oumuamua. Tabby's star is another good example. Perhaps you recall the crazily dimming star discovered by Tabitha Boyajian. Some declared that it's best explained by an alien megastructure eclipsing the star's light. That claim was on the strength that no known natural phenomena easily explained the observations. Since then, new observations have shown that the obscuring stuff filters the star's light in a way consistent with clouds of particulates, space dust, rather than an opaque object. So we're probably looking at a tidally disrupted exoplanet or an evaporating exomoon. Okay, so all of this is a bit of a bummer if you really want it to be aliens. Let's get to some hints that don't yet have satisfactory natural explanations. Many of you have heard of the WOW signal. This was a weird spike of radio emission detected by the Big Ear radio telescope at Ohio State University. There was one idea that a pair of comets were in the radio beam at the time, but the Ohio State astronomers insist that those comets were not in the beam at all. No other straightforward, generally accepted explanation has emerged, nor has such a signal ever been seen again. Or has it? On April 29th, 2019, the Parkes Radio Telescope in Australia was studying the flare activity of Proxima Centauri, our nearest stellar neighbour. A sharp spike of radio emission appeared at 982.002 MHz and then drifted upwards in frequency over a 3-hour observation. This weird signal was only spotted more than a year after the observations when a student working with the Breakthrough Listen project was reanalyzing the data. Now, there are lots of non-alien sources of radio frequency blips, mostly human-made noise, but Breakthrough Listen has detailed protocols for sifting out these false signals. According to their program, this is one of the few candidates that so far eludes natural explanation. This one is especially exciting because Proxima Cen was also recently shown to have a planetary system, including a nearly Earth-mass planet in its habitable zone where liquid water is possible. Now, the Breakthrough Listen program hasn't published its findings, so we can't say much. We know that the increase in frequency is consistent with the Doppler shift of something accelerating towards us, an invading fleet of Proximans perhaps? Or more plausibly, from the motion of a planet around the star. Now, there are very good reasons to think that this signal isn't aliens. For example, Proxima is a dangerously active red dwarf. It's unlikely that any planetary atmosphere could survive its outbursts. It's also so close. If there's a technological civilization on Proxima, that would suggest that there are many billions of them through the Milky Way, and many of them millions of years ahead of us, which means we should have seen ample evidence by now. More likely, this signal has a human source that somehow sneaked through the Breakthrough Listen protocols, or is a natural source that we just don't know about yet. Or it could be aliens, but no one's claiming aliens just yet. The fact is, no matter how long we study the universe, it will always come up with natural phenomena that we've never seen before. So does that mean we can never conclude the existence of aliens based on any observation? Should we not even bother looking? Well, not at all. I personally think that SETI programs should be robustly funded and that we should actively pursue the "it's aliens" hypothesis when warranted. The question is, when do you run to the press shouting that it's aliens? Because you know the press is going to go crazy over that, which is probably why you ran to the press in the first place. Perhaps the more useful question for most of us, though, is when do we believe some new hint or claim of the detection of alien life? Well, that's easier to answer. Optimistic skepticism is always the way to go. Believe me, if it is aliens, the evidence will mount. Most scientists do want it to be aliens more than anyone and will vigorously jump on board when it really does become more likely aliens than not aliens. But currently, it's not aliens. However, planned missions to Mars, Europa, Venus, and even the Alpha Centauri system may finally prove that we're not the only living denizens in all of space-time. As always, our deepest thanks to all of our Patreon supporters. Yes, the money is really useful. This stuff does cost a bit to make. But the other thing that's incredibly helpful is to feel your incredible support and enthusiasm. It's amazing to know there are so many people who share our love for this stuff. Now, today's special Patreon shout out goes to Leo Kogwan, who's supporting us at the Big Bang level. Leo, as your special Big Bang Patreon reward, we're going to reveal to you the true secrets of all those alien communications that astronomers have been hiding from the public for years. Then we'll introduce you to some nice Alpha Centaurians. After that, we have to neuralize you so you won't remember the details, but deep down you'll know. You'll always know. Today, we're covering comments from the last 2 episodes, our update on warp drive theory, and the one about whether dark matter can be explained by enormous numbers of black holes. TLDW, it probably can't. Askel Randelet asks whether understanding quantum gravity might be helpful for developing warp drives. Good insight. all of this warp drive stuff is pure general relativity, and we know for sure that GR is not our final theory of nature because it doesn't perfectly gel with quantum mechanics. So maybe a theory of quantum gravity will reveal that warp drives are really possible, but the opposite is also true. Stephen Hawking's chronology protection conjecture states that the universe will always find a way to make time travel impossible, and it's been speculated that quantum gravity effects will come into play for things like warp drives, whose superluminal motion must allow time travel. A simple example is that the extreme curvature in the warp bubble walls should produce something like Hawking radiation, which may obliterate anything trying to ride a warp bubble. Hall 9000 and RH2 Racing worry that warp travel is a non-starter unless there's a way to protect the ship from impacts, because hitting even a tiny particle at those speeds would be devastating. So people have actually looked into this. It turns out that if a warp bubble runs into an object, that object will become frozen at the leading edge of the bubble in a similar way to how things appear to freeze at the event horizon of a black hole. Nothing actually passes into the bubble, so the ship is safe. When the ship reaches its destination and the warp bubble dissipates, everything collected en route would be released in the forward direction. This would have so much energy on release that even just the space dust from a short interstellar trip would become a beam of energy powerful enough to destroy a planet. So yeah, don't pull up right in front of your destination, that's rude, just park around the side. Nick Williams asks what's the difference between super small black holes or naked singularities and WIMPs, or weakly interacting massive particles, a candidate for dark matter. Now, normally when people talk about WIMPs, they're referring to some undiscovered quantum particle, but actually micro black holes would have all the properties to qualify them as WIMPs, namely weakly interacting massive and particle-like. Now, fun fact, Einstein, along with Nathan Rosen, tried to explain particles in general as gravitational singularities, wormholes between adjacent dimensions threaded by electromagnetic fields. Turns out particles aren't that, but it's how the wormhole concept was invented in the first place. Philippe Chaps correctly points out that there are scientists who have pushed the black hole dark matter hypothesis for years, and so it hasn't been overlooked, as I implied at the beginning of that episode. Well, that's very fair. What I meant to say is that the hypothesis is not talked about much in the public sphere, hence the video. Mark Abella drops some wisdom from the opposite side of science, molecular biology, which is that the answer often lies in plurality. Dark matter might not be a single type of thing, but rather many different types of thing, like a dark standard model. Mark, your idea is so good that some very smart people already thought of it. For example, certain types of supersymmetric counterparts to the standard model particles might serve as dark matter. Speaking of thinking along the same lines as geniuses, many of you commented that you thought of the idea that dark matter is black holes years ago. And that is impressive. You're in the company of some very smart people in that you've all been wrong about this for years. Dark matter ain't black holes. That may have sounded unnecessarily snarky, and it wasn't meant to be. It takes excellent intuition to come up with a hypothesis that's even plausible. Actually, being right is a whole new level. Who knows? One day. Keegan Wheeler McCann offers a very nice addendum to Occam's razor. The simplest answer isn't always the truth, but it doesn't hurt to check. I like this a lot. Looking for dark matter in, say, string theory before you check whether it's black holes is like looking for your keys in the freezer before checking your pockets. And actually, if dark matter is enormous numbers of Planck mass black holes, perhaps you could actually find your keys and dark matter if you checked your pockets. More on that soon.